The invasive snakehead fish continues to spread. 81 snakeheads were caught in the Conowingo Dam this spring, a dramatic increase after only one was found there the past 2 years.
It started with one strange catch in a quiet Georgia creek.
Yep, good sized snakehead right there.
A fish that could breathe air, crawl on land, and tear through prey like a machine. But that was just the beginning. Since then, it's survived poison, outwitted flood barriers, and possibly evolved to move like a hive. From hurricanes supercharging its spread to fears of deadly pathogens and hybrids with no natural limits, what if this isn't just a fish problem anymore? The Gwinnett County nightmare. It was a quiet afternoon in October 2019 in Gwinnett County. An angler stood along a small creek, expecting nothing more than a calm day of fishing. Bass, maybe a catfish. Nothing unusual. Then his line went tight. When he dragged it out of the water and onto the bank, he froze. It looked like a snake with fins. Long body, dark patterned skin, a mouth filled with sharp teeth. But what stood out most were the eyes. They faced forward, focused, predatory, in a way most fish do not look. This was a northern snakehead. It was the first confirmed sighting in the state of Georgia, and it sent an immediate shock through the Department of Natural Resources. This was not just a strange catch, it was a warning. For years, officials believed Georgia was protected by distance and natural barriers. Snakehead populations existed far away in other regions. The assumption was simple: they would not reach here. That assumption ended on the muddy bank of that creek, because the location mattered. That creek did not stand alone. It fed directly into a major river system, a river that runs through cities, connects lakes, and stretches across state lines. Once a snakehead reaches that kind of waterway, it is no longer trapped in one place. It has a route. The Department of Natural Resources responded immediately. Anglers were told to document any catch, record the location, and kill the fish on site. No release, no exceptions. And then another problem surfaced. Northern snakeheads closely resemble a native fish species that is protected by law. The bowfin, a protected native species, has a similar elongated body and head shape. Georgia DNR identification guides emphasize checking for the snakehead's long dorsal fin spanning most of its back, which the bowfin lacks. To the untrained eye, the difference is easy to miss. Panic followed. Anglers began second-guessing every catch while arguments broke out online over identification guides. While people debated, the snakehead stayed hidden. Investigators soon realized this was not a lone fish carried by chance. The most likely explanation was human release. Someone had kept it as a pet. It grew too large. It became too aggressive. Instead of destroying it, they dumped it into the creek. That single decision may have changed everything. When officials surveyed the area using electrofishing, they did not find just one fish. They found proof of survival. The water was hot. Oxygen levels were low. Conditions that kill most fish. Temperature readings exceeded 32 degrees Celsius, with dissolved oxygen below 3 milligrams per liter, levels lethal to bass and most native species, but within snakehead tolerance thresholds. The snakehead was thriving. That discovery shattered the illusion of safety. The question shifted overnight. It was no longer, can this happen here? It became, how far has it already spread? And that realization revealed the real danger. This fish does not just survive harsh environments, it is built for them. And it does not stay where you expect it to. Evolution's perfect lethal machine. Calling the northern snakehead a fish does not fully explain the problem. It is better described as a survival machine shaped by evolution over millions of years. Most fish fail when conditions get bad. The snakehead does not. Its most well-known trait is its ability to breathe air. Normal fish rely on oxygen in the water. When oxygen drops, they suffocate. This happens often in hot, stagnant southern swamps during summer. The snakehead does not care. It has a special breathing organ that works like a primitive lung. This suprabranchial chamber allows survival out of water for up to 4 days in humid conditions, as documented in U.S. Fish and Wildlife Service field studies. It rises to the surface, gulps air, and keeps moving. While native fish weaken and die, the snakehead stays active and strong in water that looks more like mud than a habitat. But breathing is only part of the threat. This fish can leave the water. It does not flop helplessly like most fish. It uses its fins to push itself forward across land. Field observations by Maryland DNR document overland movement up to 400 meters, traveling approximately 0.4 kilometers per hour using pectoral fin locomotion. That means a pond that looks isolated is not safe. A snakehead in a ditch or drainage canal can crawl into new water without anyone noticing. Once it arrives, it dominates. Snakeheads are apex predators. Their mouths are lined with long, needle-shaped teeth designed to grip and slice. They eat fish, frogs, crayfish, insects, and anything else they can overpower. They eat constantly. Adults reach 85 centimeters and 7 kilograms in U.S. waters, and they will keep feeding until their bodies are visibly swollen. But appetite is not what makes them nearly impossible to remove. Parenting is. Most fish release eggs and leave them behind. Survival is left to chance. Snakeheads do the opposite. Both parents guard their eggs aggressively. They build nests, defend them, and attack anything that gets close. That protection allows far more young to survive. A single breeding pair can turn into a population shock in a short time. They grow quickly. They reproduce early. The cycle accelerates fast. Temperature does not stop them either. Cold does not kill them. Heat does not slow them down. They can survive freezing conditions and extreme warmth. When conditions become too harsh, they burrow into mud and wait. They do not starve. They do not suffocate. They do not freeze. This combination of traits makes them difficult to detect as well as difficult to destroy. Their dark, blotchy coloring blends perfectly with muddy river bottoms. You can look directly at one in shallow water and never see it until it moves. That is why the first discovery mattered so much. For every snakehead that is found, many more are likely hidden nearby. And while their biology explains how they survive, it does not explain how they arrived. They did not cross an ocean on their own, they were brought here. And the consequences are now unfolding. The Maryland mistake we are still paying for. To understand what is happening in Georgia now, we have to go back in time. The story starts in Maryland in the year 2002. That was the year most Americans heard the name snakehead for the first time. In a town called Crofton, a man ordered 2 live snakeheads from a market in New York. He planned to cook them for his sick sister. She recovered before the meal was made. Instead of destroying the fish, he released them into a local pond. That single choice changed everything. The discovery set off a media storm. Headlines called the fish a monster. Helicopters hovered over the water. The government responded with force. Officials poisoned the entire pond to make sure nothing survived. When they drained it, they found far more than expected. Hundreds of young fish, multiple adults. At the time, it looked like a success. The problem appeared solved. It was not. What officials did not realize was that the snakehead had already escaped into nearby river systems. Once that happened, containment was no longer possible. That moment led to a federal ban. It became illegal to import or transport live snakeheads across state lines. But laws do not erase what is already loose, and they do not stop illegal trade completely. The population in the Potomac River grew fast. By 2012, USGS estimated 21,000 snakeheads in the Potomac River system, a population that continues growing today. From there, the spread was steady and unavoidable. Virginia came next, then the Carolinas, then Georgia. The snakeheads showing up in the South are not random accidents. They are the result of that first failure in Maryland. Once an invasive species establishes itself in a connected river system, removing it becomes nearly impossible. You cannot poison a moving river. If you try, native species die first while the invader escapes or hides. Humans continued to help the spread. Some people bought snakeheads as exotic pets. When the fish grew too large or too aggressive, owners panicked and released them into lakes and creeks. A 2019 survey published in Aquatic Invasions found 24% of aquarium owners who purchased snakeheads later released them into public waters. Others spread them by mistake through bait buckets, unknowingly carrying young fish into new waters. Social media made it worse. Videos of people releasing fish for views encouraged behavior that caused real damage. All of it added up. Maryland taught a hard lesson. There is a short window to act against an invasive species. Miss that window and the fight changes. You are no longer trying to win, and you are trying to limit the damage. Maryland now holds fishing tournaments to reduce numbers. People are encouraged to eat the fish. That solution comes with its own risk. When an invasive species becomes desirable, some people start spreading it on purpose. Georgia is now standing at the same edge. The first confirmed sighting was the warning. The sightings that followed suggest the warning may have come too late. And human mistakes are only part of the story. Nature has its own way of making things worse. Why hurricanes are the ultimate superspreaders. There is one factor most people overlook when talking about invasive species: the weather. We tend to focus on human mistakes, the dumped pet, the bait bucket. But in the southern United States, the most powerful force moving invasive species is not people, it is storms. Georgia sits in hurricane country. When major storms hit, they drop enormous amounts of rain in a short time. Rivers swell, dams overflow. Ponds that were once separate become one connected body of water. During these events, the boundaries between waterways disappear. A snakehead trapped in a retention pond suddenly has a direct path into a river system. What was contained is released, not by choice, but by force. Scientists believe major storm events helped accelerate the spread into Georgia's coastal basins. Following Hurricane Irma in September 2017, Georgia DNR documented snakehead detections increasing from 3 locations pre-storm to 14 locations by 2019 in previously unaffected coastal watersheds. The timing fits a clear pattern. A storm hits, waters mix. 1 or 2 years later, reports begin to surface in places that were previously untouched. And it is not just adult fish being carried downstream. Snakehead eggs float. They contain an oily structure that keeps them near the surface. During floods, those eggs can travel long distances, sweeping over embankments and into clean waters. A single storm can move thousands of eggs without anyone seeing it happen. Containment becomes nearly impossible. You can build barriers. You can install nets. None of that stops floodwater. When major rivers overflow, swamps that have been isolated for decades suddenly connect. Temporary water highways form and snakeheads move through them easily. After the floodwaters recede, native fish suffer first. Many become trapped in shallow pools and run out of oxygen. The snakehead does not. It breathes air. It stays alive. It feeds on what is left behind. When one pool dries up, it moves to the next. This ability to survive floods, droughts, and oxygen loss is why containment plans keep failing. Maps show borders, but water ignores borders, and this fish ignores the limits of water itself. The ecological impact follows quickly. In areas where snakeheads establish after floods, populations of native fish drop. Young fish are hit hardest. Without juveniles to replace adults, the ecosystem becomes unbalanced. Predators remain. Prey disappears. Eventually, the system collapses. In the Potomac River, native largemouth bass populations declined 60% in established snakehead zones between 2005 and 2015, according to Maryland DNR fisheries monitoring data. The state has turned to technology to keep up. Environmental DNA testing allows officials to detect snakehead presence from water samples. The technique identifies genetic material from scales, mucus, and waste at concentrations as low as 0.1 DNA copies per liter. It helps confirm where the fish has been, but it has limits. In muddy, fast-moving rivers, genetic traces break down quickly. By the time a positive result appears, the fish may already be far away. Catching them is just as difficult. Snakeheads hunt at night. During the day, they hide deep in vegetation or mud. Even electrofishing only works if the fish is exposed. What remains is a predator that uses natural disasters to spread, hides during daylight, and survives conditions that kill other fish. And this is where the concern deepens. Because biology, history, and weather may not be the full story. some researchers now believe there is something else we are missing: the behavior advantage. What makes snakeheads exceptionally difficult to control is not unusual intelligence, but documented behavioral flexibility. Research from the Smithsonian Environmental Research Center shows northern snakeheads exhibit strong site fidelity. Tagged individuals in the Potomac return to the same hunting locations with 85% consistency over 30-day monitoring periods. This spatial memory means cleared areas are quickly recolonized by the same fish returning from adjacent habitat. Parental care also exceeds initial predictions. A 2016 study in the journal Capea documented male snakeheads defending fry for up to 8 weeks post-hatching in U.S. waters, nearly double the 4 to 5 week duration observed in native Asian populations. Extended parental protection significantly increases juvenile survival rates compared to native species that provide no care. Dietary flexibility compounds the problem. Virginia stomach content analysis reveals rapid prey switching: spring, spawning sunfish; summer, crayfish; fall, juvenile catfish. This adaptability means snakeheads simultaneously impact multiple levels of the food web. Laboratory studies at North Carolina State University in 2018 demonstrated snakeheads learning maze navigation to reach food. Success rates reached 73% after just 5 training trials, indicating behavioral plasticity that allows rapid adjustment to new environments. None of this suggests unusual intelligence, but it reveals an invasive species that remembers locations, protects offspring longer than native fish, switches prey opportunistically, and learns from experience. Standard removal strategies target predictable behavior. Snakeheads do not cooperate with those assumptions, and while behavioral challenges complicate control efforts, an invisible threat may pose even greater risk. The plague in the water. There is another danger that does not bite. It spreads quietly. Invasive species rarely arrive alone. They often carry parasites, bacteria, and viruses that local wildlife has never encountered. The animals that evolved alongside those pathogens may tolerate them. Native species often cannot. That is why disease is one of the most serious risks tied to biological invasions. Documented parasite transfers have already occurred. A 2013 parasitological survey in the Journal of Parasitology examined 236 Potomac River snakeheads, identifying 18 parasite species. 6 were non-native to North America, including Asian tapeworms from the genus Bathriocephalus. The concern is spillover. The same study found native largemouth bass in snakehead-occupied waters carrying 3 of these Asian parasite species. Never before documented in Chesapeake Bay bass populations prior to snakehead arrival, bacterial transmission is also documented. Aeromonas hydrophila, present in invasive snakehead populations, causes hemorrhagic septicemia in native fish during environmental stress. Maryland DNR documented localized bass die-offs in 2014, where post-mortem analysis revealed Aeromonas infections in high snakehead density waters. The fish disease columnaris, caused by Flavobacterium columnari, shows elevated prevalence in mixed snakehead native fish populations. A 2017 Virginia study found columnaris infection rates in native species increased from 4% to 19% in waters where snakeheads were established. Parasites and bacteria do not require direct predation. Shared water is sufficient. When an invasive species carries pathogens that native fish never evolved defenses against, population impacts can exceed direct predation losses. You can remove individual snakeheads. You cannot remove the microscopic threats they leave behind. While disease transmission is measurable, the next concern involves genetics, and it may fundamentally alter the invasion trajectory. When adaptation changes the game, this is the part that worries biologists the most: hybridization. When an invasive species enters a new environment, it usually competes with native species. Sometimes it replaces them. In rare cases, something more dangerous happens. Closely related species meet and breed. That is when the rules change. In the United States, there is more than one species of snakehead. 3 snakehead species are established in U.S. waters: northern snakehead, Channa argus, spreading through the mid-Atlantic and southeast; bullseye snakehead, Channa maruleus, in Florida; and blotched snakehead, Channa maculata, in Hawaii. The northern snakehead is the most widespread. Other snakehead species exist in different regions. If these invasive strains overlap, hybrid offspring become possible. Hybrid vigor is a real biological phenomenon. It means offspring can be stronger, faster, and more adaptable than either parent. Now imagine what that could mean here. A snakehead with the cold tolerance of northern populations combined with the heat tolerance of tropical strains would have no seasonal limits. It could survive winter in the mountains and summer in the swamps. That kind of fish would not be restricted by climate. It could occupy nearly every freshwater system in the region. There is another concern layered on top of that is salt tolerance. Snakeheads are freshwater fish, but they can already survive in slightly salty water. Estuaries and river mouths slow them down, but open ocean still acts as a barrier. That barrier is one of the last natural limits on their spread. Laboratory studies in Environmental Biology of Fishes, 2019, found northern snakeheads surviving salinities up to 10 parts per thousand for 96-hour periods, higher than earlier tolerance estimates, though still below the 18 to 20 part per thousand range typical of estuaries. These reports are still being studied, but they raise an uncomfortable possibility. If snakeheads adapt to tolerate salt water for even short distances, river systems stop being isolated. A fish could move down one river, pass through coastal water, and enter another. At that point, containment becomes meaningless. There are signs of rapid adaptation already. In some southern waters, snakeheads are growing faster than predicted. Adaptation to new environments occurs rapidly in invasive fish species. Whether Georgia populations show measurable differences from northern populations remains under study. Evolution does not wait for permission, it responds to opportunity. What began as an isolated introduction has turned into a moving system that adapts, spreads, and reshapes the environment around it. The question now is no longer whether snakeheads can survive here. They already have. The question is how far adaptation will take them, and whether our response is moving fast enough to matter. Because once evolution tips the balance, there is no reset button, only consequences. Thanks for watching. See you in the next one.